Hi, I'm Vaishnav, and this is my DEX order execution engine. Before the demo, let me explain the architecture. The main components are DEX router, Boolean queue, which is the queue, and Postgres for persistent storage. Basically, the DEX router uh, is the router that fetches and compares prices between Radium and Meteora to find the best rate. And we'll have WebSockets for the uh, order execution and the Boolean queue for concurrent ordering of the request. The system queues incoming orders and processes them with a concurrency limit. Currently, it is set to 10, ensuring that the server never gets overwhelmed during traffic spikes. And we have Postgres SQL as a persistent storage for improved reliability over in memory storage, ensuring no data loss, even if the service restarts. So this is the flow of the order. Initially, when we submit an order, it will be at the pending status. Then it will be uh, taken to the routing stage and then to building. Then once it is submitted to the blockchain, it will be the submitted stage, and finally, like we have a confirmed order. These are the status updates. Ideally, we would connect this to the Radium or Meteora SDKs on DevNet. However, for this demonstration, I have implemented a simulated execution layer to showcase the system's core reliability. The reason why I opted for the simulation is that we can push the queue's concurrency limits to demonstrate high throughput processing without being bottlenecked by DevNet rate limits. Also, the real networks are unpredictable. So we have to deal with the blockchain failures. And one another reason is like it is easily interchangeable. We can swap this mock with the real SDK in a simple way, making the system switch. Now let's get on to the demo. So I have created three connections, concurrent connections to the backend. We have one connection here. The second connection, which is another for from token is Solana to Bitcoin, and another one is Ethereum to Bitcoin. I'll execute all of them at the same time, and we can see the different statuses of the transaction. Initially, we have pending status, and then routing stage. Then we have it selected Meteora, and we have building state, and we have submitted. Once we submit to the blockchain, and we finally have the Meteora. We finally have the confirm state when the transaction is executed. And we can see that it executed at this price using the Meteora DEX. Similarly, here also we have all the statuses, and it also uh, executed via Meteora. And this one, you can see the price. This is also executed, and you can see that the DEX here it is Radium. And the metrics of this particular of our system here. Uh, we have total 4 transactions. We currently have 3 WebSockets, and as you can see, we have completed uh, 4 transactions. And we can even get the particular detail about a particular transaction using this URL. So you can see these details like what is the type, market type, and you can see this tokens, amount, and the status, and the DEX router used. and all these transactions are persistent in the Postgres DB. Uh, this architecture ensures a scalable, reliable, and production-ready foundation for any index aggregator. Thanks for watching.